Hi students, and welcome to another HSC Chemistry video, this one in the acidic environment topic. And today we're going to have a little bit of a look at non-metal oxides. Now, one of the important things that we need to be able to do is to identify the acidic or basic nature of different oxides. And this is going to have a fairly significant impact on some of our later studies in this particular topic, including things like the formation of acid rain. So it's probably a good idea if you're watching this video if you have a periodic table in front of you. I'm not going to flick through it while we talk through it, but if you don't, then at least if you picture the periodic table, you notice right on the far right hand side of the table are the noble gases, and just next to those are the non-metals. So the non-metals include things like chlorine, oxygen, nitrogen, fluorine, iodine, and so on. When these react with oxygen, they form what we call non-metal oxides. And there's a couple of examples here. So sulfur plus oxygen will produce sulfur dioxide, gas at room temperature. Nitrogen and oxygen can produce a couple of things, nitrous oxide, nitrogen dioxide, a couple of different options for the combination of nitrogen and oxygen. And of course, carbon and oxygen also combine to form carbon dioxide. So each of these is what we call a non-metal oxide. And what's important about these is how they behave when they're in water. So when we dissolve these in water, what we find is that if we can test these with one of the indicators that we were talking about on previous videos, particularly something like universal, then we find that the solutions that are produced are acidic, that is, they are less than 7, and sometimes quite significantly so. So you can see one example here where sulfur dioxide dissolves in water and it produces sulfurous acid. Now this also happens for something like sulfur trioxide, which also can dissolve in water, and in this case will produce sulfuric acid. Notice the difference in the anion here. And this one, sulfuric acid. Now both of these have implications if the water in which they're dissolving is part of the clouds, because then you get acid rain. So when we start to have a look at each of these, we find that there is a range of not only different types of acids, but also different strengths of acids that are a result of the nature of each of these different types of non-metallic oxides. And we'll actually look at things like strength and concentration as descriptors of solutions a little bit later in another video. But you'll notice that in the previous slide I talked about the formation of sulfurous acid when sulfur dioxide is dissolved in water. And the main reason for that is this increase in hydrogen ions in the solution. Now both nitrogen dioxide and carbon dioxide can also increase the hydrogen ion concentration. If we look at carbon dioxide, for example, then when it's dissolved in water, it will also produce an acid, in this case carbonic acid. And the carbonic acid again will result in an increase of the concentration of hydrogen ions. This is concentration of hydrogen ions, and therefore a decrease in the pH value, and an indicator of an acidic solution. One thing that I'll mention now and talk about a little bit later on is that this particular acid is not as strong as, for example, the sulfurous acid back up here. So there's a characteristic of acids that sort of changes, and most rainwater will have the presence of carbonic acid in it and therefore be slightly acidic, but hopefully most won't have the stronger acids like nitric from nitrogen dioxide, nitric acid, nitrous acid, sulfuric or sulfurous. Thanks for watching.